Hey GED students, I really want to talk to you about the multiplication algorithm, not so much how to do it. I've encountered very few students who can't do a basic multiplication problem with multi-digits among the adults that I teach in GED classes. The problem is not so much that you don't know how to do it, it's that you don't know why it works. And that little thing shows that you don't know the why shows when we get to algebra, when we get to fractions, because you don't understand why you're doing what you're doing, you make a lot of weird mistakes when we begin to explore things that are different than whole numbers, like decimals and fractions and um, algebra and all kinds of things. So let's just look at why the multiplication algorithm looks the way it does. So I'll just remind you what I mean when I say the algorithm. Most of you do not have 231 times 3 memorized. Most of you would sit here and go, okay, I'll write 231 on the top, I'll write 3 on the bottom, and then I'll multiply the way my second or third grade teacher taught me to, or maybe your GED teacher, I don't know. And that being said, when you multiplied, you would kind of pass out. You would go 3 times 1. And then when you were done multiplying the 3 times 1, you would do 3 times 3. And I'd get 9. And then when you were done multiplying the 3 times the 3, you would multiply the 3 times the 2 and get 6. And then you'd go 693. Interesting though, a lot of you guys don't understand why multiplication works this way. So let's take a look at that. So in order to look at the why, I'm looking at a virtual manipulative from coolmathforkids.com. I love this virtual manipulative. It's known as base 10 blocks, and it's super helpful. So the first thing I'm going to do is I'm going to represent the number 231. And how am I going to do that? I'm going to take 200 blocks. These are 100 blocks. I can tell because they're 10 by 10 squares, 10 rows, 10 columns, or another way to think of it is 10 rows of 10 squares each gives me 100 squares. So right there, I hope you can see I have two hundreds. I just pulled out 200s blocks. Yes, I'm overlapping them. There they are, 200s. But this number is not just 200. It's 230. What do I mean by 30? I mean 3 tens. So let's pull out 3 tens blocks. Or I should call them 310 strips. So we have a strip here of 10 blocks each. So I have now 230, and now I just need a 1 in the ones place. So 231. So there's a picture of 231. Now, what am I saying if I say 231 times 3? Well, one way to think of it is that I have the number 231 3 times. So let's take this exact configuration and repeat it. We need this exact same configuration 3 times. So now I'm going to grab another 200s. And I'll kind of overlap them a little bit to give myself room, but hopefully you can see there's another 200s. And another 30. 231. And then another 231. Remember, we said this thing was happening 3 times. So let's do it again. There's 200 and 10, 20, 30, 1. So I hope you agree that on my screen here, I've represented the number 231 3 times. Okay, now let's go ahead and realize that the most important thing you need to understand about addition and subtraction, whether you're in second grade or fifth grade or 12th grade or college math, this concept is always true. You can only add and subtract the same kinds of things. So when I go to group my stuff, I'm going to group first all my ones together. Now notice I have 1, 1 happening 3 times, or 1 times 3. And that's exactly the first act you did when you multiplied. The very first thing you did was you said, I'll have my 1 happen 3 times. 1 times 3. Now the next thing I have, the 3 tens in my number from 231 had 3 tens, also happened 3 times. So 3, 6, 9. I had 3 times 3. Or 9 strips of 10, 90. 3 threes. It's not really 3 threes, although that's what we write. What you really have here is 3 strips of 10 happening 3 times for a total of 9 tens. I should have used a different color there. 3 strips of 3 tens happening 3 times gives us a total of 9 tens, or 90. Okay, great. Now let's look at our hundreds here. Well, I had the 200s happening 3 times. 2, 4, 600 blocks I end up with. One, they're hard to slide around. I hope you'll just agree with me. That's 1, 2, 3, 4, 5, 600 blocks, meaning that 200 happened 3 times. Once again, let's bust out another color for that. 200s happening 3 times as well gives me 600s. And that is how I end up with the number 693, because I was repeating the entire number, all of the digits within the number, the ones, the tens, and the hundreds, all got multiplied by 3. Great. Now, this problem is a little simple because it doesn't have what we call carrying. So let's look at a problem where you could see some carrying, some regrouping is another way we might call it. Okay, so let's look at something a little bit bigger here. Let's look at 265 times 2. Now, once again, I don't think that you don't know how to do this problem. I hope that you do, but let's model it so we can see why it works the way it does. Here is 200. 60 would mean 6 strips of 10, 6 tens. And 5 here means, in the ones place, means I have 5 ones. Now, this number, 265, can be modeled this way with 200s, 6 tens, and 5 ones. But it can also be repeated. I could repeat this exact modeling scheme. I could do this same scheme 2 times. So right now I have it 1 time, so let's do it a second time. 200 and 60, 1 10, 2 tens, 3 tens, 4 tens, 5 tens. Sorry, I got a little messy there. 6 tens. 260, and now we need our 5. But only if I can figure out how to work the machinery here. 1, 2, 3, 4, 5 ones. Now, when we go to multiply this, something interesting happens. I mean, if you guys were doing this sucker with the standard algorithm, you would probably write the 265 up top. And this is the way, probably your second, third grade teacher taught you to do it, or else your GED teacher. You would write the 2 on the bottom and you'd multiply. And then you'd kind of start passing that 2 out. But let's think about what happens. 2 times 5 is 10. It's like 10. And so what do you usually end up doing? You write a 0 right here for 0 ones, and then you put this random 1 up here. What am I trying to say by that? Well, let's take a look here at these 5 ones happening 2 times. So that's my right-hand column over here. So I have, let's group them all together. 1, 2, 3. You know what? I think I want to do it this way so you can see it. 4, 5, 6, 7, 8, 9, 10. Oh, I don't have enough space on my page to show it to you. Let's see if I can group it. Nope, it won't let me. Okay, so the point though, I put these guys together and I end up with 10 blocks. It's another strip is what it is. And maybe I can put it on this side. There we go. Okay, so what I end up with is an additional strip of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have no leftover ones, but I do have a 10. And so that's what I'm doing here. As I write the 0 down here, I'm saying there's no single ones, but I did end up with a 10 strip right here. And that can go in with my other 10 strips. So now I have a total of this one I just built, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you go, Kate, I don't do it by counting. I know you don't do it by counting, but look what you do when you do this. You say, I'm going to take 2 times 6, 2 groups of 6 tens. That's 12. And then you add in the one group you got before from the tens. That's 13. Now, interesting thing with um, when you have 13 strips of 10, you have more than 100, don't you? In fact, oops, let's go put the 3 over here because 100 would be 10 of these. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows of 10 is 100. So yes, when you have 13 tens, you actually have 3 plain old 10 strips, 3 plain old 10 strips, and one group of 100. One group of 100. See how I'm regrouping when I have enough to go in the next column? So now I carried my 1 into the next column. Now let's take a look at your hundreds now. Now you had your original 2 groups of 2. That's 4 groups. But now you just made another group. So I end up with 5 total hundreds groups. And that's exactly what you would see if you did the multiplication. 2 groups of 2. 2 times 2 is 4. Add in the one group I carried from before, and that's 5. And so I find out that 265 times 2 is the same as 530. All right, if you have any questions about this or any other GED math concept, be sure to drop it in the comments and I'll do my best to answer it.